In this video, we're going to be taking a look at a free fall problem where a ball is dropped from a 4-meter tall building, and simultaneously someone has to throw a ball upwards so that each of the two balls land at exactly the same time. So the first thing we're going to do is we're going to go ahead and label all of our known variables. So if we take a look at our orange ball, if it's dropped, we know the initial velocity is 0 meters per second. We know that the acceleration due to gravity is negative 9.8 meters per second squared. And we know the delta y because of the 4 meters of the height of the building. So we're going to call the delta y negative 4 meters because it has been displaced downwards 4 meters from its original position. Now, if we take a look at the second person, we're looking for their VI. We know that they are going to experience the same acceleration due to gravity as soon as the ball is released. And then from there, we don't know very much. So we're definitely going to work over here on the left side with our orange numbers. The reason we're going to do that is because we really don't have much to work with in this region over here with our purple numbers. We only have one value. Now, we know that the connecting factor between the two is the time because we're looking for both of these objects to land at the same time. So the thing that makes the most sense is to solve for t. Now, if we have these three known variables and we're solving for time, the only formula we can use is this formula over here, our second formula. So let's go ahead and plug in our numbers into the second formula and see what we get for time. All right, so I plugged in all of our numbers into our second formula, and I condensed it down because this is all 0. 1/2 times negative 9.8 is negative 4.9, so all I had to do is divide both sides by negative 4.9, and then square root it for our total time in error of 0.9 seconds. Now we're going to go ahead and take the time of 0.90 seconds and plug it in over here. And we still have too many unknowns because for all of our acceleration formulas, you need 3 known variables to find a 4th unknown. So there's an important free fall concept that we're going to have to use here, which is if something is tossed up with a certain initial velocity and it comes down back to the same level, it's going to have the same final velocity, but it's going to just be a different sign. So these two are just opposite signs of one another. So you can say that VF is equal to negative VI, or vice versa, VI is equal to negative VF. So if we use that idea, we can go ahead and use this formula right over here because that involves VF, VI, and the A and T that we already have. So we can say that negative 9.8 equals, and then instead of having two unknowns, a VF and a VI, I'm going to replace the VF with negative VI. So negative VI minus VI over 0.90 seconds. Now, if we do that, we can go ahead and take this over here and turn it into negative 2 VI. And then we're almost there. We can go ahead and just cross multiply the 0.90 over to the other side, which is basically the same thing as multiplying both sides by 0.90. And then we can go ahead and divide both sides by negative 2 as well. Okay, and then our answer is going to be 0.90 times negative 9.8 divided by negative 2, and that equals 4.41 meters per second for our initial velocity. So when solving a problem like this, you want to make sure you keep your numbers organized, label all your known variables, find the right formulas, and then find a time from one side, like we did over here at this green box, and translate it over here And then you're going to have to use, like I said, one of those free fall concepts like we did over here, finding out that the initial velocity and final velocity are the same but opposite signs. And you can use that to your advantage in this setup over here to find initial velocity of 4.41 meters per second. So I hope that was helpful to you. Thank you for watching and listening.